Ladies and gentlemen, good morning. Today I'm going to introduce a computer game designed to train eye contact for children with autism. Children with autism often exhibit characteristics like lack of concentration and poor eye contact. If not intervened early, this issue can persist and cause more problems as they grow up. This study aimed to design a computer game to help autistic children aged 3 to 10 improve their attention and eye contact. The eye contact is a fundamental form of social interaction. Research shows that eye contact can regulate the activity of social brain networks, helping individuals better understand others' behaviors and emotions. For autistic children, the lack of eye contact can affect their understanding of facial expression and social cues. Although behavior therapies for autism is effective, it is expensive and hard to access widely. Game-based interventions are gaining attention due to their flexibility and low cost. Existing studies have shown that digital platforms are feasible and effective in treating children with autism. We interviewed several parents of autistic children to understand their views on current intervention and training programs, and we collect their feedback on the game design as well. Parents believe that the game should be both entertaining and challenging to better capture their children's attention. The game's core is a story about protecting a carrot garden. Players need to interact with the game characters using eye contact to progress. Using eye tracking technology, players can interact with characters in the game, complete tasks, and protect the carrot garden. Players must be focused, talk, and observe to advance through different scenes. Each game lasts 2 to 5 minutes, creating a tense atmosphere through sound and animation. Prompted by the bird, players quickly make eye contact with the rabbit within 0.4 seconds to 3 seconds to claim the rabbit and protect the carrot from the thieves. The game uses implicit memory formation rather than explaining the rules to children in advance. Players learn through exploration, discovering that eye contact and gaze duration trigger the game actions. This is a low fidelity of the game, and we did some UI design. This is our visual reference. So we break the game into many segments, each made into video. Using Python's weather loops, we bridged the segment and connected the eye tracker data to the program. We first conducted a game solution performance test. We recruited autistic children in the rehabilitation center and then arranged game equipment in the game room. After each game class, the rehabilitation therapist invited the interested children and their parents to participate. A total of 6 autistic children volunteered to participate in the game. They sat at the game table accompanied by their parent to participate in the game. Among them, 3 children were able to pass smoothly and 3 failed. 2 failed halfway, and 1 child's face and eyes could not be recognized by the eye tracker. To further verify the effectiveness of the game, we conducted 2-week long-term follow-up experiments with 4 tests in total. The testing method including classroom observation by rehabilitation therapists, parent feedback, and data collection during the game. Evaluation indicators include eye contact time, game engagement, and class record. This is a finding of the experiment too. Through the analysis of the game process and subject records, we found that the subject is becoming more and more proficient in the skill required to pass the game, for example, eye contact and stay focused. The subject's eye contact and posture are more natural. In summary, the game was highly evaluated in terms of novelty, practicability, interactivity, ease of use, and safety. Half of the autistic children were able to participate in the game, and the game helped improve the eye contact, gaze, posture, and attention of the autism children to a certain extent. So that's all. Thanks for listening. See more detail in the full paper. Thank you.